So in this video, we're going to model this assembly in Inventor, and I'll have another video where I model this in Fusion 360. This PDF should be linked in the description, so you can download this and model this along with me. So we'll start with the simple parts, save the hard parts for the end. So go ahead and download it, put it on your other screen, and we'll start modeling. So we'll start with this lead guide. So this is going to all be in inches. All right, so start a new part. And I'm going to save it in a new folder as PP01. And this is just going to be a simple extrude. So I'll start a sketch and do 2 circles. .036 and .020. That's it. Finish sketch. And we'll extrude that as .142. And it says the material is mild steel. All right, that part is done. Save it. We could maybe give it some eye properties. Tell it that the description is lead guide. If you don't want your designer and author to come in as your Windows login name, you can change that in your application options right here. So now any design I do will auto-populate with SRW. So we'll save that and move to the next one. I'm going to skip to PP03. It's again just another ring. So I'll say new standard part, new sketch, and again, this one gives me a wall thickness, so I think I'll do a shell for this one. So 0.331 is the OD. Make sure that's fully constrained. Finish sketch, extrude. It is a thickness of 0.059. And then you can say shell and pick right through the top and the bottom. Pick the top and the bottom. And then this is your wall thickness. It's one way of doing that. There's a lot of ways of doing that. And again, this is mild steel. I'll change my eye properties. You can see this came in as SRW this time. And this is just ring. And we'll save that as PP-03. PP04 is kind of the same thing, but we could do this as a revolve, but I think it'll probably be easier to stack 2 cylinders on top of each other, and then we'll do a counter bore hole. So this will end up being 3 features. So PP04 is next. So again, I'll start with a circle. The OD is 0.118, and I'll extrude that up 173. Put a sketch on top of it. 0.071, and extrude that up 0.299 minus 0.173. We'll go to the bottom of this, and we're going to put a counter bore hole on this. So click the face, click anything round, it should center it. And I'm already set up for simple counter bore hole. And the counter bore diameter is 0.051. The through hole is 0.039. And our depth, 0.069. That should be it for that part. The material is ABS plastic. And we'll set our description. And save this as pp-04. See if there's anything else easy in here. I'm running out of easy parts. Oh, pp-11. It's just a sleeve, mild steel. So we'll do a new standard part and just a circle. And I'm going to use shell again with a wall thickness of 0.008. This is mild steel. Let's go to the last two pages of the PDF, PP14, PP15. This is the eraser. PP14 is the eraser. It has an OD of 157, and that's going to go up 0.413. And then there's a fillet on both ends of 0.02. This is rubber, but then I'm going to change the material, the appearance. Let's see if we can find a pink in here. There's a pink. That's our rubber eraser. So we will give it a description of eraser and save it as PP14. That's print. I did Control P instead of Control S. So this is a bottom-up design where we're doing all of the parts and then coming back and putting them in an assembly, not working in a single assembly. The eraser cap is PP15, the last sheet. Again, just a simple cylinder. And then we could do a shell because you can change the thickness of a face with a shell. But we don't know the wall thickness without doing math, so I think I'll just put a sketch on this face and extrude the ID down. So that's going to be a cut. And I'll do the overall length 0.551 minus that bottom thickness of 0.039. We need a fillet on the bottom. And that should be our eraser cap. We'll make that mild steel. Although this title block says that it's just steel, everything else was mild steel, I'm going to keep it the same. And we'll save that as PP15. All right, now I think we'll go back to the beginning and just work through these, what's left from start to finish. We kind of did the easy ones. We'll just start at PP02. So I think I'll start this with a revolve and get the outside shape. So we'll put a sketch on a plane, and the overall length is 0.638. That kind of sets my scale so I can zoom in on the sketch. And I'm going to turn that to a center line. That's what I'm going to revolve around. That'll let me type in diameters as well. And then kind of just eyeball this shape. Oh, I didn't do a very good job of eyeballing this shape, did I? Now let's bring you back here. And you, something like that. That's about right. So, get our overall diameters on here. I get out of the dimension command and kind of fix this a little bit. Just make sure when you're dragging this around you don't accidentally add constraints. If you do, you have to F8, find the constraints. If you accidentally add a parallel by dragging it around, you have to F8 to turn on your constraints. F9 turns them off. You can also toggle them on and off down here. Show constraints, hide constraints. All right, this to this center line is, and this to the center line is, and I'm fully constrained. And we should have a closed profile here. So we'll finish sketch and revolve. If I go to home view so I can kind of see what's going on, that looks like what I'm after. So I think this, just keep breaking this down into simple shapes. I'll do that hole in the top there is 0.204, and it goes down 0.203. And then we have a through hole. No counter bore. This will just be where the lead is going through, or I guess that lead guide's probably stuck in this hole. 0.035, and that is a through all. Because of the dimensions that we have for that last little bit, and I could offset a plane, but I think that last little bit I'll just do, I'll put a sketch through the center of this and slice my graphics down here. I think that's F7 if you're into hotkeys, and I'll do the last two little holes in here. Get some geometry to work off of, so I projected the y-axis and then this axis with project geometry. I'm going to turn this line into a center line because I will be doing a revolve, and then I'll draw this shape. And that should give me a closed profile. So perpendicular, perpendicular, that looks good. Oh, that's not what I want. I'm going to dimension that height. And this height. And I just need my diameters. Oh, there's no lip here, so I'm going to have to delete this line. Redimension this height. There we go, and we're fully constrained. Finish sketch and revolve as a cut. And OK. And that should be that part for us. This is mild steel. And give it a description. That is PP02. PP05 is the next part. Now, because of all the tapers, I think I'm going to do, for my base profile, I'm going to do a revolve to start out, rather than stacking a bunch of cylinders. So my overall height is 0.394. That kind of, again, sets my scale, so I know I need to zoom way in. Otherwise, you draw the whole profile, and then everything is way too big or way too small. And I'm going to make that line a center line. So I think the taper on this is starting at the bottom of that extra feature. So I'm actually going to do, for this, I'm going to start my taper at 0.325 minus 0.01. And then I'll base that little flange that's right here at this location. Since on this print I'm not given that. So I'm fully constrained, I can revolve this. We have a hole running through this with a 1 degree taper. So I'm not going to use the hole command. I'm actually going to put a sketch on this and extrude it with a 1 degree taper. All right, so when I extrude this, I'll say through all as a cut, and then I'm going to add a taper angle. So if I say 20, just to make sure I'm going the right way, that is the right way. That's what's going to have a 1 degree taper. Actually, it's against itself, so I think this would be 0.5. Because it's a 1 degree taper from inside wall to inside wall, not from a vertical line to the one inside wall. So I think this is a 0.5 to get me that 1 degree taper. And to get the final little profile on here, we'll put a sketch on a plane and slice our graphics. And we're going to draw this little feature. So I'm going to start the bottom lip on this transition where it starts to taper in. It kind of goes up pretty shallow, then it goes straight up, and then back into the part. And this is 0.005, and I have an overall of 0.01. I'm going to need a center line, so I think I'll project an axis. So I select an axis and hit project. I can make that a center line, and now when I dimension, it'll be a diameter. And I'm fully constrained, so let's revolve this and see what it looks like. And I think that is that part. So this is PP05. And it is mild steel. All right, save it and close it. And we'll do the next one. PP06, ABS plastic. I think I'm going to start with 2 cylinders stacked on top of each other. And another sketch for our next cylinder. And it is 0.787 minus our first cylinder, 0.48. I'll do the inside while I'm looking at it like this. So I'll put a hole through here and say counter bore. We'll do the 2 top sections going through there. So the counter bore diameter is 0.134 with a depth of 0.087. And the overall, or the through hole, would be 0.118. And then I'll do a hole on the bottom. And this will be a through hole, not a counter bore. And it's going to be, not a through hole, sorry. It's going to have a depth of 0.787 minus 0.236. Probably isn't the best way to do this one. Diameter of 0.165, and I don't want a drill bit point. See, it's got a drill bit point. I want that to be flat. I don't know. Probably would have been faster to just extrude a circle on there and extrude it, or draw a circle and extrude it down. Then we have some flats on this. So I'll put a sketch on this face right there. And look at that. And let's just do one on the top here. So I'll project my perimeter and draw 3 lines. Looks like it's trying to snap me to quadrants. I'm going to have to come way over here so it doesn't snap me to quadrant. If you put an equals between these two, that'll center it up, see, because we're going over center. So if I say equals constraint right here, equals, since it's going over center, that forces it to be center. So that centered it for us. Then we need a depth. So the depth to the center, 102, and it has a width of 0.057. That's it, fully constrained. Let's extrude that as a cut. 0.094. And we'll circular pattern that feature around this axis. And we need 1, 2, 3, 6 of them. All right, I think that part is done. This is shaft. Spelled that wrong. And ABS plastic. And we'll save it as PP06. I'm going to draw the spring. So we'll start a new part and define the wire diameter and a center line, which I guess we could have projected an axis for that as well. I'll tell you what, rather than do the math for this, if you dimension the line and then hover near the tangent point, so that's going to snap to center, that anywhere on the circle. Looks like it all wants to snap to tangent point. Usually you can't get that tangent symbol on your cursor. So the idea of this is 0.106, and we want a horizontal off of 0. So it's fully constrained minus the height of my center line, but that doesn't really matter. We'll do a coil, and we know 9.25 revolutions per the print, and we know height center to center. So we know revolution and height. It's already picked our profile, already picked our axis. If you didn't make this a center line, you may have to pick the axis. 9.25 revolutions and a height of 0.366. And per the print, I may need to go the other direction. So let's flip it, see if that matches the print. Yes, that matches the print. This is per the print, mild steel, and the description. Spring. .008 is a little bit of a cup. Rather than do this as a revolve, let's do this as cylinders. A revolve is too easy. Extrude that lip as 0.01. So that's our top lip. Then we know we want to go 0.075 off of this and draw a circle that is 0.109, and then extrude it out with a taper of 20 degrees. So we could have done this with a revolve, but this lets us play with work planes. So I'm going to pull a work plane off that face, 0.075, put a sketch on that work plane, and draw a circle 0.109. turn this work plane visibility off. I usually right click and just hit V to turn the visibility off instead of scroll down to it. When we extrude this, we're going to extrude to that face with a taper angle of 10 degrees. So 10 off of vertical. The print shows 20, but that's from side to side. We've got looks like several fillets of 0.004. Got one here and here and oh, we haven't cut the middle out yet. We can't do a fillet yet. We haven't cut the middle out. Consistent walls of 0.01. So this would be a shell with 0.01. If you want to see what that looks like, we'll look at a cross or a section view. So it just gave us consistent wall thicknesses of 0.01. Now we can add our fillets. Put a fillet on there and there and there of 0.004. Again, we could cut this hole out of the bottom with a revolve, but I think I'm going to keep trying to use different features just to show different methods. I'm going to draw the top circle and finish that sketch, and I'm going to go to the bottom, put a sketch on that face, and draw a circle that is the bottom. So now I have my two circles, and I can loft between them. So I can pick that circle and say cut. And that should remove that material and should give me that taper. So this is mild steel. That's a print. I don't know why I'd keep doing Control P, probably because of the files being named PP. That is part PP08. PP09, ABS plastic shaft. Let's could do a revolve, but it'd be a pretty busy sketch. So I think I'm going to get the outside shape by stacking cylinders. Simple way of looking at this. So I'll start on the right side, 0.097, and that's going to go up 0.256. Looks like I have a double dimension on this print. 256 is on both views. I'm going to work my way up. The next cylinder is the largest cylinder, 0.244, and it's going to go up 0.469 minus 0.256. I'm subtracting the cylinder below it. Another cylinder, 0.197, and it's going to be 3.035, and then minus my two cylinders. Actually, just minus the 0.469, I guess. It gives, that would be the two cylinders stacked on top of each other. That would set that height. We have two more cylinders to stack. This is probably the long way of doing this. Revolve probably would have been faster. This is 3.78 minus 3.053. And then the last little cylinder is 0.118, and it goes up 3.906 minus 3.78. There's my cylinders. I'm going to save this. It's PP09. I got enough work in here. I don't want to lose it. It looks like there's a hole 0.163 going down 0.256. Then we have a hole that is 0.150 going down 3.701 minus my 0.256. And then we have a final hole that's just going to be a through all hole. That is, I should have probably done this with the hole command. That's just going to be a cut through all. And the only thing it's going through is that little section. So we should have 3 series of holes through there. I'm going to guess this is a 45 chamfer. The distance of this offset. .007. Is that what I'm reading? So if I say chamfer of 0.007, .0065. I'm gonna have to do the math to actually figure out what this is. So let's see. We have 0.563 minus 0.150 divided by 2. So this is okay. So it is 0.0065. All right. So that's my chamfer there, and then we have a 45 here, whatever this distance is. So if I measure there to there, 0.024, 0.024. And again, it failed, so I'm going to guess there's a precision thing happening here. So let's change my precision. So 0.0235. 0.0235. All right, that was probably the long way around doing that. Maybe a couple revolves, 3 or 4 revolves might have been a little bit faster. Oh, we're not quite done. We have a little notch. On this face. So we're going to draw a rectangle. It looks like it's cut the whole way through. Coincident constraint. And this, come on, quit picking the dimension. This is 0.079, and then that's going to cut into this 0.126. So I think that's that notch that's on the top there. All right, ABS plastic, and save as. Oh, I already saved it, so we just need to change our description. That part should be good. Let's see what's next. PP10 is the grip. I'm going to do 2 cylinders again. Thinking. Let's just get some geometry out here, and we may have to rethink some things once we get started. The overall, we're not told if that's a 45. Tell you what, I'm going to back up and do this as a revolve, because that chamfer at the top, we're not told what angle that is. I have a feeling it's a 45, but we don't know. So I'm going to do this overall shape as a revolve. Make that a center line. And then I can get this revolve done right. And I'm going to actually model the grip part that we're going to cut later, I think so. Let's do something like this. So we know this was the thing that's making me do the revolve. So let's start up here. This is 0.272, and then this is 0.315. And I know this dimension and this dimension. I'm going to see if that's a 45. Yeah, it's probably supposed to be a 45, but it wasn't dimensioned very well. And we know that the little rubber piece that's sticking out is, or I'm assuming maybe it's just molded plastic, but that grip part that's sticking out is 0.011. And we'll say it starts at 0.06 and it goes up to 0.91 times 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 solids. I think that's what I want. How does this line know what it's supposed to be? Come on. Okay. That coincident constraint right there got added when I drew it. So this point has to be in line with this line, which is what I want, but I didn't mean to do that, and it works out. So we'll revolve this and put our hole through the center, because why not? Concentric circle through all 0.224. All right, let's do the first revolve. I'll look at detail G and do the first revolve, and then we'll pattern that up. So I'll find a sketch that works through the center, or a plane that runs through the center, and put a sketch on it. F7, slice your graphics, and I'm going to project that edge and this edge, I think. Let's project all of this. So I'm going to draw a circle whose center point with a coincident constraint is on this line. I thought I hit coincident. And it is tangent to this line with a radius of 0.023. I think that's what I want. Let's do a revolve and see. So cut that out around that axis as a cut. And then I'll pattern that in the y-axis in my case. I think I said there were 13 of them, so I'm going to need 14 of these, and their spacing is 0.091. And I think that's what I want. Then we'll do the cut on this side. So let's put a sketch on this face. And we're going to draw a circle that is vertically aligned. So I'll say vertical. And it is tangent. So I'm going to project my inside circle and say tangent. And it has a radius of 0.026. And that's going to be my cut running down through there. So extrude, cut all. And I will circular pattern that. And there are 6, so there's 12 of these. That should be the grip that is modeled or drawn on the print. I think that completes PP12, so save as PP-12, set its material as mild steel, and give it a description for our parts list. All right, we're done with that. I just saved that as PP12. I did just save that as PP12. That's supposed to be PP10. Because PP12 is what's next. I think I had my papers a little bit off and I seen PP12 sticking out from beneath. So for PP12, since we've done stacked cylinders a few times, I'm going to do this as a revolve, which is probably how I should have done that one with all the cylinders we stacked. This is typically how I do something that's a series of cylinders like this. I just do some rectangles and make one of them, one of the lines, the center line for my dimensions. So let's set the scale of this 0.315, and then we're going to say these are collinear, and this diameter is 268. Then we can do the lengths. Oops, I already got that. All right, fully constrained, and we'll revolve everything, and it found my center line, so it just went with it. This has a straight through hole, of 0.252, couple chamfers, that is the difference between 0.315 minus 0.268 divided by 2, so these chamfers are going to be 0.0235. Now we just need to do this little build-up on the one side. So I'm going to project the outer ring and just draw 3 lines. And I gotta do a horizontal on that line and an equals between them, and that should center it. $217 for the overall, and it's going something like that. .472. Then it looks like the sides are cut off. So I'll just keep working on the top, I think. I'm going to draw a rectangle here. And might as well do the other side. I could mirror it, I guess, but 118. I'll throw an equals between these, and let's do a collinear again. And I know that this is 227. So that little chunk needs to go away. So cut, let's say to this face, just in case material comes out there one day, I won't do a cut all. Then we're going to put a rectangle on this and drill or do this slot that's running down inside here. So this is 0.028 thick. .177, and I'll say horizontal, and the back side is 0.160. So there's the hole that's going to go down in there, fully constrained. Extrude that as a cut, and we're going to go in 0.354. And then it looks like it's cut out right here. So I'll put a sketch on this face and project that edge. So that gives me that edge to work with, and I'll just draw a rectangle off of that. And then the only thing I need to do is how far down that goes, which is 0.031. So that's fully constrained, and I'll extrude that to this face. And I think that is that part. So ABS plastic, give it a description for our parts list. There we go, PP-12. The last piece we need is PP13. Looks like all the dimensions are to the inside. So I think I'm just going to do this as one continuous line. I'll start at the top, I guess. So let's do a circle that is 0.051. Kind of sets my scale. And then I want a line that comes straight down 0.13. And this is 20 degrees. Something doesn't look right. This is a diameter and should be a radius. All right, do another line off of this side. Draw another circle and get this vertically lined. What I'm going to do is I'm going to draw the inside path and I'm going to sweep a rectangle along that path. That's what I'm working on here. So this radius is 0.071. They are not vertically in line. This line is tangent. Looks like I'm missing a tangent up here as well. So I think this is all dimension. I'm going to trim this out. I typically don't trim, but in this case I'm making a path. I do have to trim that out. And on the bottom side I'm going to come up tangent. Now when you start a line off of a circle, if it's like normal to the center point and you hold control or shift, sorry, if you hold shift it locks you normal to the surface, but if you let go of shift then you're back to just drawing. And in this case I want it to be, you know, kind of off. I don't want it to be vertical because that's a constraint. I'll have to go delete, but I do want it to be tangent. So if you hold shift, this line will follow the circle and stay tangent, and then I can kind of draw it off on purpose and add that 1 degree that we have in this, and I have my tangencies. So now I can trim this out. And the overall length of this, I'm going to guess that's an aligned dimension. Should be. If it's not, it may not be, but it's going to be, in my case, 0.335. So I have a fully constrained path ready for my rectangle. So this is the inside. So when I draw my rectangle, I need to make sure it's attached to the inside. Just to kind of, we could put a sketch on that plane and draw our rectangle at the top of that arc or the bottom of this arc. We could put a sketch on this plane and draw the rectangle through here. But to show another way to place a plane is normal to a curve at a point. And I can pick a point and then a curve, in this case a line. And that plane is rotated 1 degree from the origin planes. And now I can put a sketch on that. I'll project this point and draw my rectangle. And I'm going to constrain this to the center so that it's sweeping, and that is the inside all the way out around. .028 and 0.177. So that's our rectangle. Don't like seeing my planes, so I'm going to turn that off and do a sweep. So it picks my profile. Now you can see the blue line underneath my sweep. It wants me to pick the path. And that should be that clip. So this is steel, it says. We'll go with mild steel. And give it a description and save it. So we have the whole thing. I'm going to go back to the first page of this PDF and we'll put some assemblies together. So new assembly. And I'm going to save this as my housing assembly. And I want to bring in, there's all my parts and my housing assembly. And I need PP 3, 10, and 11. So I can hold Control and pick 3, 10, and 11. This is one way to get a bunch of parts in an assembly at once. And there we go. They're all sitting on top of each other. So let's save this. And PP03 is the one that's constrained at 0, 0. That was the first one that came in. I don't want that to be the grounded one. I probably think this one should be the grounded one. So I'm going to say ground at 0, 0 right here. So you want to ground it at origin? Yes, I do. So now this part's origin plane matches the assembly's origin plane. And then I'll constrain this together. So it's probably going to be something like this. And like this. Okay, so I see that slides the whole way in. So let's edit that. There we go. Okay. So we can save this. Maybe give it a description. And start a new assembly. So I'm going to start with that housing assembly and constrain everything to it, I think. So a quick way to get these in is you can, if you already have it opened, so there's my empty assembly, I can right click on this and copy, go back over here and paste. And that's the first one in, and it has a thumbtack, so it is grounded. We're good to start bringing things into this. So something on this needs to be threaded. We don't have any threading on any of these parts, so it is what it is. This is a sample data set just for drawing. I'm sure the original pencil that Mark Flaler drew that I stole this from, I'm sure he had threading in it and I didn't see it. Didn't think about it. So we're going to pretend, maybe we can come back and edit these and add the threading. We'll do that as we bring them in. So I think I'll start at the back and work my way forward because everything seems to stack off the back. So I'm going to bring in number 10. Balloon number 10 on that first page is PP12. So Bring this piece in. Don't want two of them. And then we'll bring in PP9. Get 9, and then maybe that clip too, which is PP11. No, it's not 11. It's balloon 11, it's PP13. We can constrain this together. So let's put this together. And then we'll find an origin plane. So XY, and then we'll find the origin plane that this runs through. XZ, so constrain those two planes together. That's the wrong way, so I'm going to flip it. Okay. Then we just need a height on this. Something like that. It's probably a touch too far. It's probably hitting in there. So let's constrain this together with an insert. And I think I'm going to press lock because I don't want that rotating. Here's where we're supposed to have some threads, I think. I think I'm going to add some threads. So I'm going to go into this part and say threads. And we'll go with UNF. And then we'll go back to this part and put some threads in here. UNF. Oh, not the whole way though. We'll go 1/4 of an inch. Oh, that's okay. Yeah, I don't have the diameter quite right, but now I have threads where that would screw in. And we can put the next piece in. So let's see where this guy would go. We'll go back to another insert off of, we'll go to the top. See what that looks like there. And I have a feeling maybe it's off the back. Don't think we're going to know this until we get the rest of the stuff stacked on here, how this is going to go together. So let's just get a few more parts. And I think I'm getting sidetracked. We'll do the eraser and I'll get the cap. We can put those in. Insert constraint, And then we'll do the cap. Looks like number 6 comes into here, and I'm going to guess it's probably threaded as well. I don't think I'm going to take someone else's model next time. I'm going to actually measure my own, and then I'll know how it goes together a little better. But this is probably going to be mostly just insert constraints. I bet you that goes all the way down to there. And our spring will come in. PP07. This might actually sit on top of all of this, but I'm going to make it go inside. Why is that not flipping? Oh, my mate is one direction. We'll say allow any direction. Now this constraint should work. And we have the little cup that's on the back side. That is PP8. And then the next thing is number 5, PP5. And this little guy probably goes something like that. And then we have the final cone and the tip. So PP1 and 2, bring them both in at once. change this to just be a mate center line to center line. And then that's going to allow me to do an insert on the cone. And again, I'm missing some threading on this piece and this piece. But anyway, this was not supposed to be creating a pencil that you could produce. This was just supposed to be some modeling practice. I didn't expect to get so bogged down in the assembly. So, you know, we got some stuff that's not threaded, and I definitely had some issues putting this together, but let's just look at this as a practice drawing, practice 3D modeling, and leave it at that. So I think what I'm going to do is just place one view and get a section view. And then maybe a detail view. And a parts list. And we'll call it at that. So then we can come through and balloon this. We created a presentation view as well to create the exploded assembly, but I think I'm going to model this in Fusion in another video, and then from this point forward I'll model stuff that I'm measuring myself and have a better idea of how it goes together. This one kind of caught me towards the end there on assembly. If the threads had been in place, I think it would have made more sense on how it was supposed to assemble, but not having the pencil in hand made this a little bit more difficult. So good luck.